10 days. That's how long a visitor from another star system sat quietly inside a telescope's memory before a single human being noticed it was there. Not because the telescope missed it, it saw it perfectly the very first night it appeared. It just took 10 days for anyone to go back and look. And when they finally did, scientists realized something that should unsettle you more than any staged clickbait headline ever could. A newly built observatory in the mountains of Chile had already captured evidence of an object from outside our solar system before the rest of the world's astronomers even knew it existed. That is not a hypothetical. That already happened. Right now, the same machine is sitting on a mountaintop, wide awake, photographing the sky every 40 seconds. And nobody, not one person on this planet, knows exactly what it has already caught sight of that we simply haven't gotten around to checking yet. And it is only the smallest preview of what this machine is about to do to our understanding of the sky above us. This is the story of the Vera C. Rubin Observatory. And if you've never heard of it before, that's about to change fast, because what it just started doing as of the final days of June 2026 is going to surface more unknown objects in our solar system in the next 12 months than humanity has documented in the last 2 centuries combined. Let's start with what this thing actually is, because the scale of it is almost hard to describe in a way that doesn't sound exaggerated. Sitting at nearly 9,000 feet above sea level on a mountain called Cerro Pachon in Chile, the Rubin Observatory houses the largest digital camera ever constructed. It weighs about 3,000 kilograms, roughly the weight of a loaded pickup truck, and its images are so large that you would need hundreds of ultra-high definition television screens lined up side by side just to display a single one of its photographs at full resolution. It captures light using a 3,200 megapixel sensor, a number so far beyond a normal camera that comparisons start to lose meaning. And unlike almost every telescope that came before it, Rubin isn't designed to stare at one tiny patch of sky for a long time. It's designed to do the opposite. Every few nights, it photographs the entire visible southern sky over and over again for the next 10 years straight, building what scientists are calling the greatest cosmic movie ever made. The observatory is named after Vera Rubin, the astronomer whose work in the 20th century gave us the first solid observational evidence that something invisible, something we now call dark matter, is holding galaxies together in ways that visible matter alone cannot explain. She never received a Nobel Prize for it while she was alive, despite the fact that her discovery reshaped the entire field. Rubin Observatory exists, in large part, to finish the work she started, hunting for the fingerprints of dark matter and dark energy hidden across the structure of the universe. But almost immediately, before it had even finished getting fully calibrated, it started finding things that had nothing to do with its original mission at all. To understand why this telescope is capable of things nothing before it could do, it helps to understand what it's actually built around. At the heart of the observatory sits the Simone Survey Telescope, paired with a camera the size of a small car, engineered specifically to capture enormous swaths of sky in a single exposure while still resolving incredibly faint, fast-moving detail. Most large telescopes throughout history have made a trade-off, either seeing a wide area of sky in low detail or seeing a tiny sliver of sky in extraordinary detail, but rarely both at once. Rubin was built to break that trade-off entirely, combining an unusually wide field of view with a level of light-gathering power that lets it pick out objects roughly 6 times, fainter than what most existing asteroid hunting surveys can detect. That combination is exactly why it's been able to find things nobody else has, not because it's simply a bigger telescope, but because it was designed from the ground up to notice motion and change across almost the entire sky at once, night after night, rather than staring at one fixed point. Back in June of 2025, the observatory released its first test images to the public, in an event astronomers had been anticipating for years. One of those images, built by combining over 600 separate exposures, taken across just 7 hours of observing time, showed the Trifid and Lagoon nebulae in a level of detail that stunned even the scientists who built the machine. Another image, nicknamed the Cosmic Treasure Chest, contained roughly 10 million galaxies in a single frame, a number that is genuinely difficult to hold in your head. In that same short test window, lasting barely 10 hours of actual observing time, Rubin quietly discovered over 2,000 asteroids nobody had ever cataloged before, including several near-Earth objects. For comparison, every other observatory on the planet combined discovers roughly 20,000 asteroids in an entire year. Rubin found 10% of that number before its real mission had even officially begun. Then came February 24th, 2026, a date that deserves more attention than it got. On that night, our engineers switched on Rubin's real-time alert system for the first time, a feature designed to flag anything in the sky that changes, appears or disappears between one image and the next, within a single night, pointed at a patch of sky the telescope had already mapped before, so it had something to compare against. Rubin generated 800,000 individual alerts on 800,000 things that were different from what had been there before. Exploding stars, asteroids in motion, flickering variable stars, distant galactic cores flaring with activity. All of it cataloged automatically in a single night from a telescope that hadn't even started its main 10-year survey yet. And then, just over a month later in April of 2026, came the number that should have made front-page news everywhere and mostly didn't. Scientists confirmed that a single batch of early data, gathered over roughly 6 weeks of pre-survey testing, had revealed more than 11,000 new asteroids. The 11,000 objects in our own solar system that nobody on Earth had ever seen or tracked before that moment. Hidden inside that batch were 33 previously unknown near-Earth objects, asteroids whose orbits bring them relatively close to our own planet. To be clear, none of those 33 pose any known danger, but sit with the number underneath that fact for a second, because it's the part that actually matters. Scientists studying near-Earth objects estimate that we have only identified around 40% of the mid-sized asteroids out there, the ones larger than about 140 meters across, the size range capable of causing serious regional damage if one were ever on a collision course. That means, as of right now, more than half of the objects in that dangerous size category have never been seen, tracked, or cataloged by anyone, anywhere, ever. Rubin alone, once its full survey ramps up, is expected to uncover close to 90,000 additional near-Earth objects. Some of those, by the observatory's own projections, may turn out to be potentially hazardous. I want to pause here and be completely straight with you, because this is the point where a lot of channels start inventing danger that doesn't exist, and I'm not going to do that to you. None of the objects found so far threaten Earth. This isn't a story about an incoming asteroid. It's a story about how much of the sky directly around us has simply never been looked at closely enough to know what's actually there. For the entire history of astronomy, we've been observing space in scattered snapshots, watching small patches of sky for short windows of time, and hoping we happen to catch anything moving through it. Rubin is the first instrument ever built that photographs almost the entire visible sky, repeatedly, continuously, for a full decade, which means for the first time in human history, very little out there will be able to hide from us for long. That's not a threat. That's arguably one of the most important defensive tools our species has ever built. Rubin's own mission scientists describe it as central to planetary defense, precisely because you cannot prepare for what you cannot see coming. And until now, we've effectively been driving through a crowded intersection with our eyes closed most of the time, hoping nothing was in the way. This telescope, for the first time, finally opens them. But that same open eye also means the coming years are going to force us to confront just how much has been sitting undetected above our heads this entire time, quietly, the whole way through human history, without a single one of us knowing it was there. Which brings us back to that interstellar visitor I mentioned at the start, because this is the part of the story that genuinely gave scientists chills, and for very good reason. In the summer of 2025, an object called 3I/Atlas was spotted moving through our solar system on a trajectory that made it immediately clear it didn't originate here. Its path was too fast, too steep, too clearly foreign to be anything born in our own solar system. It became only the third confirmed interstellar object ever detected passing through our cosmic neighborhood, following 2 previous visitors that made headlines around the world when they were found. But here's the detail that turned this into something stranger than a simple discovery. When astronomers later went back and checked Rubin's early test data, the data gathered before the observatory had even officially started its survey. They found that Rubin had already captured images of that same interstellar object, 10 full days before anyone else on the planet had identified it. The telescope had seen it. The evidence was sitting there, quietly, inside a dataset nobody had reason to search through yet. It simply took 10 days for a human being to go looking in the right place and realize what had already been photographed. There's one more discovery from those early months worth sitting with, because it's the kind of detail that sounds almost too strange to be real, and yet it's fully documented in a peer-reviewed paper. While combing through Rubin's first batch of asteroid detections, a team led by astronomer Sarah Greenstreet identified 19 asteroids spinning at astonishing speeds, objects astronomers call super and ultra-fast rotators. The most extreme of them, a rock designated 2025 MN45, measures about 710 meters across, nearly twice the height of the Empire State Building, and it completes a full rotation in just 1 minute and 53 seconds. Think about that for a second. A piece of rock the size of a small mountain spinning fast enough to complete an entire rotation before you could finish reading the sentence out loud. It is, as far as anyone has recorded, the fastest spinning asteroid of its size ever found. And it had been sitting out there undetected until a telescope finally had the sensitivity to catch it mid-spin. Now project that forward, because this is where the story stops being about the past and starts being about what's coming. Scientists working with Rubin have said publicly that they expect the observatory's 10-year survey to detect somewhere between 5 and as many as 500 additional interstellar objects passing through our solar system. A range so wide it tells you how little we actually know about how often visitors from other star systems pass through our neighborhood. Every single one of those objects represents a genuine, standing scientific mystery, a piece of another solar system entirely, drifting through ours, carrying information about a place we will likely never otherwise be able to study up close. And thanks to Rubin's real-time alert system, the next time one appears, we may not need 10 days to notice it. We may know within hours. There's another thread running through Rubin's early data that deserves its own spotlight because it touches on one of the oldest open questions in modern astronomy. Deep in the outer reaches of our solar system, far beyond Neptune, Rubin's testing phase has already turned up close to 380 previously undiscovered trans-Neptunian objects, icy bodies orbiting in the cold, dark outskirts of our solar neighborhood. 2 of them, given the provisional names 2025 LS2 and 2025 MX348, were found to have extraordinarily elongated orbits, stretching out to distances roughly 1,000 times farther from the Sun than Earth itself, placing them among the 30 most distant objects ever recorded in our solar system. Discoveries like this matter enormously to scientists hunting for what's sometimes called Planet 9 arc, a hypothetical large world that some researchers believe may be lurking undiscovered in the solar system's outer darkness, its presence inferred only from the strange, clustered orbits of smaller icy bodies out there. If a world like that actually exists, Rubin is, by a wide margin, the best instrument humanity has ever built for finally proving it. Mario Juric, the University of Washington scientist leading Rubin's solar system research team, put it plainly. He said that discoveries which used to take years or even decades to make will now happen in a matter of months, and that this early batch of findings is, in his words, just the tip of the iceberg. And that iceberg only started actually forming on June 30th, 2026, just over a week ago, as I'm telling you this, when the observatory's real 10-year mission, called the Legacy Survey of Space and Time, officially began. Every single thing I've just described to you, the 11,000 asteroids, the 800,000 alerts in a single night, the interstellar object hiding in plain sight for 10 days, all of that happened during testing, calibration, and early optimization, before the real survey had even started. The actual 10-year mission is now live, scanning the sky every 40 seconds through the night, generating roughly 20 terabytes of raw data and up to 7 million alerts every single night once it reaches full operational speed. Over the course of a decade, scientists expect Rubin to roughly triple the total number of known asteroids in our solar system and expand our catalog of distant trans-Neptunian objects by nearly a full order of magnitude. In its very first year of full operation alone, researchers are projecting it will uncover around 1 million previously undiscovered asteroids, a number equal to what the rest of human astronomy managed to catalog across the previous 2 centuries combined. So here's what I actually want you to take away from this, because it's more unsettling, in the honest sense of that word, than any manufactured scare could ever be. For the entire span of recorded human history, we have looked up at the night sky and assumed that what we could see was more or less what was there. A telescope like Rubin proves, almost casually just by turning on and quietly doing its job for a few months of testing, how wrong that assumption has always been. There is an interstellar visitor that slipped past every telescope on Earth for 10 straight days before anyone realized it had already been photographed. There are tens of thousands of asteroids in our own solar system, some of them in the size range capable of real damage that nobody has ever tracked, ever named, ever seen before this year. There may be a 9th planet hiding in the dark beyond Neptune that we are, for the first time, actually equipped to find. And all of that came from testing. The real mission just started a little more than a week ago, and it is going to run for the next 10 years, photographing the same sky over and over until almost nothing up there is left unseen. We spent centuries believing we understood our own solar system. Rubin Observatory has been operating at full strength for barely a week, and it has already suggested we understood far less of it than we thought. Consider what that actually means for a moment. Every asteroid ever discovered before this year, going back to the very first one, found in 1801, represents roughly 2 centuries of patient, painstaking human effort. Astronomers, squinting through eyepieces and later through digital sensors, tracking faint points of light across the sky one at a time. Rubin, in its very first year of full operation, is projected to match that entire 2-century total on its own. Not because human astronomers before it were careless or unskilled, but because no instrument before this one was ever built to look at the whole sky, continuously, with this level of sensitivity, for this long. We didn't have a blind spot because we weren't looking. We had a blind spot because nothing we'd ever built was capable of looking everywhere at once. The question now isn't whether it's going to keep finding things we never expected. Based on everything that's happened just in the testing phase alone, that's already a certainty. The real question is what happens the first time it finds something we genuinely don't know how to explain. If you want to be here when that happens, subscribe and turn on notifications, because Rubin's alert system is active right now, scanning the sky as you're watching this, and we'll be covering whatever it turns up next. Drop a comment telling me what you think is more likely to be lurking out there waiting to be found, a genuine ninth planet or something we haven't even thought to imagine yet, because after this week, I'm not ruling anything out.